Welcome to my YouTube channel. So in this video we're going to look into this question for optimization. The diagram shows a semicircle on the top of a rectangle and the perimeter of the shape is 20 centimeter. Find the maximum area of the rectangle. So here we are given a perimeter. So when it comes to the perimeter, so we need to consider all of this. And then this part of it. So actually we need to walk around the shape. So here if we wish to find the perimeter, so the perimeter is basically here, this is h, so this is h, and here since this is a semicircle, so this line is showing a diameter, so that means this is the radius and this is also radius, so that means this length is 2r. And then here this is the semicircle, so circumference of a semicircle will be half of the circumference of a circle. So here since the semicircle the circumference of the circle is 2 pi r, so divided by 2, so it will be pi times r plus h and another h, so which is 2h plus 2r. And then we are given that this perimeter is equal to 20 centimeters, so pi r plus 2h plus 2r. And then from here, now here it's asking the maximum area of the rectangle. So now since we know the rectangle is only this part of it, so we know the length of the rectangle is 2r and the width is h. So that means the area of the rectangle is equal to 2 times r times h, since length times length and width. So from here we can find, because we need to maximize the area, so we need to there are two variables, so one of the variables should be eliminated, so we will use this equation. So from here what we can do, we can move these two to the other side, so get h, so this will give us h is equal to 20 minus pi r minus 2r divided by 2. So now from here we can replace h over here into this equation. So we can see this 2 and 2 will cancel out. So then we will get the area equation, which is 20r minus pi r square minus 2 times r square. So now from here what we need to do, we need to solve for this one to find the derivative. So we'll find the derivative to look for the stationary point. And then here this is 20 minus 2 pi r minus 4r. So if we set first derivative equal to 0, so we will get the value of r, so that will be 20 divided by 2 pi and plus 4. If we simplify this, so this is 10 over pi plus 4, or pi plus 2, yeah. So we need to divide, we need to take 2 as a common, so 20 divided by 2 is 10, and then in the denominator we'll get pi plus 2. So then from here we know this value, and then we need to check whether it's a maximum or not, so we will use a second derivative test. So where we end up with the first derivative, so we can continue. So if we find the second derivative, so d square a over dr square will be equal to minus 2 pi and minus 4. Okay, so from here if you see, this is already less than 0. So if the second derivative is less than 0, so therefore at this point when r is 10 over pi by 2, so you can say here at r is equal to 10 over pi plus 2, there is a maximum. But at the end he said find the maximum area. So now in order to find the maximum area of this rectangle, so you remember this was the area equation, so we can plug the value of r over here. So 20 times r, which is 10 by pi plus 2 minus pi times 10 by pi plus 2 whole square minus 2 times 10 by pi plus 2 whole square. So if we calculate this, so we will get 19.45 centimeter square approximately. So that's what it was required. So we found the maximum area of the rectangle. So hope this is clear to you. Thanks for watching.